Welcome to Unit 2 on sampling methods. So the objectives for this unit are going to be learning the reasons for sampling, developing an understanding about different sampling methods, distinguishing between probability and non-probability sampling, and the relative advantages and disadvantages of each of these approaches. As we know, a sample is a smaller representation of a larger population that still is able to determine truths about that smaller population. Why do we sample? Because number one, we have lack of resources, which might be time or money, as well as workload implications and busy schedules. A sample also gives results with known accuracy that can be calculated through different statistical means. Something that we have to consider is a sampling frame, which is the list from which the potential respondents are drawn, whether that be a registrar's office, class roster, a class of students, or students at a particular school, for instance. Sampling frame errors, such as university versus personal email addresses, changing class rosters, those sorts of things, you have to ensure that all the students in the population of interest are actually represented in your sample. There's three factors that influence a sample's representative nature. The first is the sampling procedure, another is sample size, and the last is the participation or the response, the return of whether it be a survey or a consent, permission, that sort of thing. When might you sample the entire population? When the population is small, when you have lots of resources and money to conduct these research projects, as well as when you may not expect a very high response. If we break down a sample, we have to think about who do we want to generalize to, and what population can I potentially gain access to? How might I do that? And who's going to be actually in the study that I'm going to be investigating? So we go from a theoretical population to the actual study population, and then the sampling frame that we consider all goes into actually selecting your sample. This is a visual that I like to use where you think about the target population is the whole group, and the study population is a smaller representation of that group that hopefully you can generalize to, and a sample is going to be a component of that study population. There are several types of probability samples. These include simple random samples, such as systematic random, stratified random, multi-stage samples, multi-phase samples, and cluster samples, as well as non-probability samples, such as convenience, purposive, and quota-based samples. We're going to go through each of these. Again, when you sample, you need to consider several things. First, defining the overall population of concern, which was addressed in the other PowerPoint that we did this week. Second, specifying a sample frame or a set of items or events possible to measure. Third, specifying a sampling method. Fourth, determining the sample size. Fifth, implementing the sampling plan. Sixth, sampling and data collecting. And finally, seventh, reviewing the sampling process. So again, your sampling frame it has the property that we can identify every single element and include in our sample. The sampling frame must be representative of the overall population. And it's possible to identify and measure every single item in the population and to include any of them in our sample. However, more than likely, this is not going to be possible. So again, we do the best we can to still represent the overall population. In probability sampling, in this scheme rather, it's one in which every unit in the population has a chance, that is greater than 0, of being selected for the sample. When every element in the population does have the same probability, it's known as equal probability of selection, EPS. That kind of design is also referred to as self-weighting, because all the sample units are given the same weight. Again, these are the types of probability samples that we will go through now. In non-probability samples, it's where some elements have no chance of being selected. It also involves the selection of elements based on assumptions regarding the population of interest, which forms the criteria for selection. For example, if we visit every household on a given street and interview the first person to answer the door, in any household with more than one occupant, this is a non-probability sample because some people are more likely to answer the door. That is, those who are unemployed, perhaps mothers at home taking care of kids, etc. Non-probability samples include accidental sampling, quota sampling, and purposive sampling. In addition, non-response effects may turn any probability design into non-probability design if the characteristics of non-response or responses are not well understood, since non-responses effectively modify each element's probability of being sampled. In simple random sampling, this is applicable when a population is small, homogeneous, and readily available. It provides for the greatest number of possible samples. This is done by assigning a number to each unit in the sampling frame. A table of random number or lottery system is used to determine which units are selected. In this case, estimates are easy to calculate, and simple random sampling is always an EPS design. Some of the disadvantages are if the sampling frame is large, this method might be impractical. Minority subgroups of interest in the population may not be present in the study in sufficient numbers for the actual overall study. We have to consider the replacement of selected units. For example, if we catch fish, measure them, and immediately return them to the water before continuing with the sample, this is a WR design. This is meaning with replacement. So just like in elementary mathematics, we have to consider with or without replacement in regards to a sample. Systematic sampling relies on arranging the target population according to some ordering scheme and then selecting elements at regular intervals through that ordered list. In this case, we have to think about the fact that it's important that a starting point is not automatically the first on the list, but is instead randomly chosen from within the first to the xth element in that list. So that a simple example would be to select every 10th name from the telephone book, also referred to as sampling, with a skip of 10. Systematic sampling is an EPS method, as we said, because all elements have the same probability of selection. It is not simple random sampling because different subsets of the same size have different selection probabilities. Example, in this picture here below, the set has 1 in 10 probability of selection, but the set has 0 probability of selection. So if it's every third person in this picture, some people have 0 probability of selection. The systematic sampling has several advantages. The sample is easy to select, it's a suitable sampling frame that can be identified easily, and the sample is evenly spread over the entire reference population. The sample may be biased, however, so this is a disadvantage if hidden periodicity in population coincides with that of selection, and it also may be difficult to assess the precision of estimates from one survey. A stratified sample is one where a population embraces a number of distinct categories. The frame can be organized into separate strata. Each stratum is then sampled as an independent subpopulation. Every unit in a stratum has the same chance of being selected. In stratified sampling, since each stratum is treated as an independent population, different sampling approaches can be applied to different strata. Some drawbacks include using stratified sampling. The sampling frame of the entire population has to be prepared separately for each stratum. Also, when examining multiple criteria, stratifying variables may be related to some but not others, which further complicates the design and potentially reduces the utility of the strata. Finally, in some cases, stratified sampling can potentially require a larger sample than would other methods. The post-stratification. Stratification is sometimes introduced after the sampling phase in this way. This approach is typically implemented due to the lack of prior knowledge of an appropriate stratifying variable, or when the experimenter lacks the necessary information to create a stratifying variable during the sampling phase. Sometimes we have an incident of oversampling. Choice-based sampling is one of the stratified sampling strategies. In this, data are stratified on the target, and a sample is taken from each strata so that a rare target class will be more represented in the sample, thus creating a biased sample. The effects of the input variables on the target are often estimated with more precision with the choice-based sample. Cluster sampling, on the other hand, is an example of two-stage sampling. First stage, a sample of areas is chosen, and in the second stage, a sample of respondents within those areas is selected. A population can be divided into clusters of homogeneous units, usually based on geographical continuity. Sampling units are groups rather than individuals, and a sample of such clusters is then selected. All units from the selected clusters are studied. Some advantages include the fact that it can cut down on the cost of preparing a sampling frame, and the fact that this can reduce travel and other administrative costs to create a functional sample. Disadvantages include sampling error may be higher for a simple random sample of the same size, often used to evaluate vaccinations coverage, free and reduced coverage, those sorts of things within large populations. Cluster sampling requires the identification of clusters. For example, list all cities, towns, villages, and wards of cities with their populations falling in the target area under study, calculating a cumulative population and then dividing it by 30. This gives the sampling interval. Selecting a random number less than or equal to sampling intervals having the same number of digits, forming the first cluster, and random numbers plus the sampling interval equals the population of the second cluster. This sort of process allows for the identification of clusters to occur. In cluster sampling, there's two types of cluster sampling methods. One-stage sampling involves all of the elements within the selected clusters are included in the sample. The second one is a two-stage sampling. A subset of elements within selected clusters are randomly selected for inclusion in that sample. The difference between strata and clusters is that although strata and clusters are both non-overlapping subsets of the overall population, they differ in several ways. All strata are represented in the sample, but only a subset of clusters are in that same sample. With stratified sampling, the best survey results occur when elements within strata are internally homogeneous. However, with cluster sampling, the best results occur when elements within clusters are internally heterogeneous. Multi-stage sampling. Complex form of cluster sampling in which two or more levels of units are embedded one in the other. The first stage involves a random number of districts chosen in all states, followed by a random number of villages. Then the third stage might include the unit being the houses, and all ultimate units selected as the last step in the survey process. Multi-stage sampling. This technique is essentially the process of taking random samples of preceding random samples. The multi-stage sampling is used frequently when a complete list of all members of the population does not exist or is not appropriate. Moreover, by avoiding the use of all sample units in a selected cluster, multi-stage sampling avoids the large and perhaps unnecessary cost associated with traditional cluster samples. Part of the information collected in a whole sample and part from a subsample. In this way, in the first phase, there are some surveys handed out, and in the phase 2, there are x-rays given to these, some of the cases, and then finally in phase 3, there's a sputum examination within some of the x-rays and some of the cases. Surveying by this procedure is less costly, less laborious, and more purposeful. Matched random sampling is a method of assigning participants to groups in which pairs of participants are first matched on some characteristic and then individually assigned randomly to groups. The procedure for matched random sampling can be briefed with various contexts. For example, 2 samples in which the members are clearly paired and are matched explicitly by the researcher. For example, IQ measurements or pairs of identical twins. Those samples in which the same attribute or variable is measured twice on each subset under different circumstances, commonly called repeated measures. Examples include the number of times a group of athletes for 1,500 meters before and after a week of special training, the milk yields of cows before and after being fed a particular diet, the reading scores of kids before and after an intervention, all those sorts of things. Quota sampling is the population is first segmented into mutually exclusive subgroups, just as in stratified sampling. Then judgment is used to select subjects or units from each segment based on a specified proportion. For example, an interviewer may be told to sample 200 females and 300 males between the age of 45 and 60. It is this second step which makes the technique one of non-probability sampling. In quota sampling, the selection of the sample is non-random. Convenient sampling, sometimes known as grab or opportunity sampling or accidental or haphazard sampling, a type of non-probability sampling which involves the sample being drawn from that part of the population which is close to hand, that is, readily available and convenient. This happens all the time in educational research. You have access to someone you know in a school, a class of students, etc. The researcher using such a sample cannot scientifically make generalizations about the total population from this sample because it would not be representative enough. This is an interesting depiction of someone yelling out of a building trying to harass somebody coming by in order to get a convenient sample because it was just the closest person at hand. Judgment sampling or purposive sampling is when a researcher chooses the sample based on who they think would be appropriate for the study. Maybe they're the best teachers at a school, or the gifted learners, or the struggling readers. This is used primarily when there is a limited number of people that have expertise in the area being researched. Panel sampling, on the other hand, is a method of first selecting a group of participants through a random sampling method and then asking that group for the same information again several times over a period of time. Therefore, each participant is given the same survey or interview at 2 or more time points. Each period of data collection is called a wave. This sampling methodology is often chosen for large-scale or nationwide studies in order to gauge changes in the population with regard to any number of variables, from chronic illness to job stress to weekly food expenditures. Panel sampling can also be used to inform researchers about within-person health changes, due to age, or help explain changes in continuous dependent variables such as spousal interaction. There have been several proposed methods of analyzing panel sample data, including growth curves. This concludes our discussion on sampling of probable samples as well as non-probable sampling plans, including sampling frames and the different types within each subset. I hope you've enjoyed this presentation, and I look forward to speaking with you.